A comet from another star should have been a simple story. A distant block of ice swings past the sun, sheds a little dust, and fades into the dark. But this one did something different. Near perihelion, it brightened by almost a factor of 100 and shed a large fraction of its mass, and somehow did not break apart. It survived what should have shredded it. You did not click on this video because you enjoy being scared. You clicked because you saw the words experts and fear together, and that is not something you see every night. People who spend their lives staring at the sky are not fragile. They are used to calculating impact odds for rocks that really could hit Earth. So if they are uneasy about this object, you want to know why. Not through a stream of breathless headlines, but in a calm story you can follow while you lie back and let the day fade from your body. You want to understand what is actually strange here, what is normal, and what keeps the people who study this object awake a little longer than usual. Tonight, that is what you are going to get. You will hear why this object is called Three-Eye Atlas, and what it means for something to come from another star. You will see how its size, brightness, and path already set it apart from the visitors we have seen before, sliding along the same plane as the planets and passing Mars, Venus, and Earth as if moving down a carefully drawn line. You will hear how, at the most critical point in its journey, the entire Earth was blinded by the sun. From here, the object vanished into the glare, unreachable to even our best telescopes. At the same time, Mars had a clear view. Spacecraft orbiting another world were looking almost directly at it, taking images that would not reach the public for weeks because of a shutdown that had nothing to do with astronomy. You will hear how, as it curved around the sun, it flared in brightness, like an object being torn apart and yet held together as one body. How it grew structures that looked less like a simple tail and more like jets, one reaching away from the sun, another seeming to lean toward it, against everything you think you know about how sunlight and dust should behave. You will hear about a faint radio whisper that followed, the kind of signal that has a natural explanation, but arrived at just the right moment to make careful people raise an eyebrow. And you will hear what happened when the long silence ended and NASA finally spoke, how the world waited 6 weeks for a clear picture and instead saw a small, fuzzy blur that left the hardest questions hanging in the air. The fear in this story is not about impact or destruction or any threat to you. It is the quieter fear of not understanding what you are seeing, the fear of stacking up anomaly after anomaly until the word coincidence starts to feel thin. When experts fear, they fear having to admit that the tools and models they have trusted for decades may no longer be enough. As you listen, the sky above you is calm. The planets are keeping their steady paths. Three-Eye Atlas is already on its way out, a traveler gliding back toward the space between the stars. What remains here with you is the puzzle it leaves behind. So take a slow breath. Let your shoulders drop. Tonight, you and this object will travel together. From the moment it slipped into our solar system thousands of years ago, through the moments that made experts uneasy, to the crossroads we stand at now. By the time this story settles, you will understand why people who do not scare easily have used that word at all. and you will be able to close your eyes, knowing that the universe can unsettle you and comfort you at the same time. On the first morning of July 1st, 2025, while most people on Earth moved through an ordinary day, a quiet alert appeared on a computer screen in Chile. The Atlas survey system, designed to scan the sky for moving objects, flagged something unusual. At first glance, it looked like a small point of light drifting across the dark. But the computer didn't flag it because it was bright, or because it was close, or because it was moving fast. It flagged it because the math behind its path did not belong to this solar system at all. Its orbit wasn't closed. It wasn't looping like a comet or circling like an asteroid. Its curve didn't bend back toward the sun, the way almost everything in the solar system eventually does. It was bent outward, following a shape that could only be produced by something arriving from the deep cold between the stars. A hyperbolic trajectory, the mathematical signature of an interstellar visitor. You may have seen diagrams of planetary orbits before. Circles, ellipses, shapes that return to the same place over and over again. A hyperbolic path is the opposite of that. If an orbit is a road that loops back home, a hyperbola is a highway that never returns. It is like skipping a stone across a pond and watching it slide off into the distance, never curving back toward your feet. No matter how long you wait, no matter how far you look, you know it will never come around again. This is the kind of trajectory that only objects from other star systems take. And this was the third time in human history that we had ever seen one. But it didn't feel like the third chapter of a story. It felt like something new entirely. The first visitor, Oumuamua, was small and strangely shaped, so thin and light that some scientists argued it may not have been shaped by nature at all. The second, Borisov, looked like a comet straight out of a textbook. Classic, predictable, the kind of object you'd show to a student learning about astronomy for the first time. But 3i Atlas was different from the very beginning. It wasn't small, it wasn't fragile, and it wasn't quiet. Early estimates suggested it was 2 to 3.5 miles long, a mountain of ice and rock compared to the delicate sliver of Oumuamua. It shined brighter than expected, moved with a confidence that felt deliberate, and carved a clean path through the dark as though it had traveled this way before. The early data hinted at a visitor with mass, real, undeniable mass, 1,000,000 times more massive than Oumuamua and far stranger than Borisov. It carried structure. It carried complexity. And even in the first frames captured by Atlas, astronomers could tell that they were seeing something unusual. You imagine that moment for the researchers who first zoomed in on that faint point of light. They would have checked the software. They would have checked the coordinates. They would have wondered if something had glitched. But the numbers held. The calculations repeated. The trajectory stayed the same. This object was not from here. As days passed, more telescopes joined in. Observatories across the world gathered its faint signal in visible light, infrared, and ultraviolet wavelengths. With each new observation, the same picture sharpened. The object was moving faster than anything bound to the sun. Its approach angle was unusually gentle, low, almost parallel to the plane of the planets, as if it chose a path that brought it through our neighborhood instead of above or below it. Even its brightness didn't seem to behave the way astronomers expected. It glowed steadily, showing no early signs of dramatic outgassing or chaotic shedding. You picture it now, a frozen vessel drifting through the dark. Not a machine or a ship, but a naturally sculpted traveler forged in a distant system. A block of ice older than our earliest stories. Older than the first spark that lit human civilizations. You imagine it gliding along the edge of a galactic arm, crossing the invisible boundaries of star systems like a silent drift of snow, moving across a field no one has walked on. There is a strange quiet that comes with thinking about visitors like this. Objects that wander for millions of years without any purpose other than to follow the physics that shaped them. And yet, some part of you feels the pull of meaning, not because it is artificial, but because it reminds you how wide the universe really is, and how small the set of things we have actually seen becomes when compared to everything that remains unseen. Visitors are rare. Space is vast. And from the very first frame, this one felt different. Its speed whispered of long journeys. Its angle suggested a path chosen from the plane where planets live. Its brightness hinted at more activity than expected. And its size, that immense, cold weight, made you feel a kind of quiet awe. You're not afraid of it. You're fascinated by it. You want to understand where it came from, what shaped it, and why it passed this way after so many thousands of years traveling in silence. As astronomers collected more data, the questions grew instead of settling. If it wasn't looping in from a distant part of our system, where exactly had it begun its trip? If it had come from another star, how long had it been traveling? And why did its path look so smooth, so perfectly aligned with the plane of our worlds? There is a moment in every scientific discovery when curiosity deepens into something heavier. Not fear, exactly, but a kind of alertness. A sense that you are standing on the edge of something you don't fully understand yet. That moment arrived early for 3i Atlas. And for you, listening now, the picture is just beginning to form. You know where it was first seen. You know why it raised eyebrows. You know why its journey feels different from the two visitors that came before it. But what you do not yet know is how long it has been traveling. You don't know how old its arrival is, or how deep its story goes. And the answer to that brings the first true pause in this entire journey. Because when experts traced its path backward, they found something that made everyone pause. When astronomers traced the path of 3i Atlas backward, running its motion through centuries of gravitational calculations, something unexpected emerged. The numbers pointed to a moment long before telescopes, long before modern science, long before even the idea of astronomy existed as a discipline. According to the best models, this visitor entered the solar system roughly 8,000 years ago. In cosmic terms, that is nothing at all. The universe is more than 13 billion years old. The solar system itself has been spinning for 4.5 billion. Against those scales, 8,000 years is not even a breath. It is an astronomical blink, a tiny sliver of time that barely registers in the ledger of the cosmos. And yet, it is a period that holds an enormous amount of meaning for one species, yours. Because 8,000 years ago was the moment humanity lifted its head toward the sky and began to understand that it was looking at something larger than itself. Around that time, in the land between the Tigris and Euphrates, the Sumerians carved the first symbols that would become written language. They tracked the moon. They gave names to stars. They built the first cities whose rooftops held observers watching patterns above them. Far to the west, along the banks of the Nile, the old kingdom of Egypt was rising. They watched the heavens to guide their agriculture and aligned monuments with celestial markers that still hold their precision today. To the east, the Indus Valley civilization was blooming, laying out cities with remarkable order and building systems that showed an understanding of cycles and seasons. And in ancient China, early astronomers were recording eclipses, tracking comets, and marking the rhythms of the sky with a seriousness that would eventually lead to centuries of continuous astronomical history. 4 civilizations, 4 beginnings, 4 groups of people who stepped out of the childhood of humanity and began to write their place under the stars. The moment when humans first gathered around fires, looked upward, and realized the sky was not a backdrop, but a story unfolding above them. And according to the numbers, that is exactly when 3I Atlas slipped quietly into our solar system. You imagine those early nights, flickering flames, the silhouettes of people sitting in the desert dark, watching points of light drift across a still, unpolluted sky. You imagine someone lifting a hand, pointing out a faint streak, wondering what it meant in a world that was just beginning to speak. They would have had no idea that a visitor from another star had just crossed the boundary into their neighborhood. They would not have seen it, recorded it, or understood it. But it was there, gliding silently through the outer regions of the solar system, patient enough to wait millennia before drawing close enough for anyone to notice. Of all the billions of years Earth has existed, why now? Why this moment? Why this thin slice of time when humanity had just awakened, just learned to write, just begun to map the sky above? You don't need to jump to conclusions. You don't need to chase exotic explanations. But you can allow the question to settle for a moment. There are several possibilities, each simple in its own way. The first is randomness, a cosmic coincidence with no deeper meaning, just one of countless alignments produced by the vastness of space. The second is the gentle tendency of nature to arrange itself in ways that occasionally appear meaningful, like a branch falling in the shape of an arrow, or a cloud forming a shape you recognize. And then there is the third possibility, not a claim, but simply a thought. Perhaps this is the first pattern in a chain of patterns that becomes harder to ignore as more information comes in. Scientists wrestle with coincidences constantly. Some patterns are just artifacts of the way we observe the universe. Others are products of the anthropic principle, the idea that you perceive the universe the way you do, because only certain conditions allow you to be here perceiving it at all. Discovery is shaped by perspective. The timing of what you find is shaped by the fact that your species has only been looking for a tiny fraction of cosmic time. Coincidence doesn't mean intention. It doesn't mean purpose or design. But some coincidences linger. Some of them stay with you. Not because they point to anything dramatic, but because they fit into the quiet spaces of your mind and whisper that the story might be larger than it first appears. And that is what this 8,000-year calculation feels like. Not a warning, not a message, not a sign. Just a soft knock on the door of your curiosity, a reminder that your species arrived late to the cosmic stage, and yet somehow caught this object at the precise moment it wandered close enough to be seen. The more you think about it, the more you feel the same gentle unease that astronomers felt. Not fear of danger, but the sense that the timing is almost too elegant. A visitor timed to our awakening. A traveler that entered when humanity first opened its eyes to the sky. Is it coincidence? Maybe. Is it a pattern? You decide. Because this was only the beginning. When astronomers pushed the calculations further, they found something even more precise. Something that pointed not just to timing, but to alignment. And that is where the next part of this journey begins. When scientists extended the reconstructed path of 3I Atlas across the solar system, the second anomaly emerged, not with drama or chaos, but with a precision that felt almost unsettling in its calmness. The object wasn't plunging in from above or slicing through the planetary system on a steep angle the way most long-period comets do. Instead, its orbit sat only about 5 degrees off the ecliptic, the thin, invisible sheet where all the major planets travel, as if they were beads sliding along the same quiet thread. 5 degrees. Out of all the thousands of possible approach angles in three-dimensional space, out of all the random tilts that normally shape natural long-distance visitors, 3I Atlas arrived nearly aligned with the exact plane where the planets live. You can picture it for a moment. The solar system as a vast spinning disk, and this object coming not from above, not from below, but almost perfectly along the rim of that disk, as though it knew where the lanes were. One astronomer described the odds with a metaphor that stays in your mind for a long time. He said that if most comets are like darts thrown in a dark room, landing wherever they happen to fall, then 3I Atlas was like throwing a dart from another continent and having it land exactly on the dividing line between two numbers. Not close, not almost, right on the line. You let that image sit with you. A dart traveling light years that lands precisely where space is thinnest. A stone skipping across the pond of the solar system, choosing a path that runs nearly level with every major world. It does not prove anything, but it does make you look a little longer at the diagram. Because most comets don't do this. Their orbits tilt sharply. Their angles are wild. They come down steep, or they shoot across at harsh diagonals, or they sail far out of the planetary plane altogether. The solar system sees thousands of natural approach paths, and almost all of them, almost every single one, miss that narrow band by a mile. The randomness is enormous. The spread is wide. Nature does not usually thread needles, but this object threaded one. And then the trajectory revealed something even more elegant. As scientists calculated its upcoming motion, the flyby sequence formed a pattern that made people blink. Not in fear, but in a kind of quiet disbelief. Before reaching the sun, the object passed near the orbit of Mars. After looping around the sun, it swept inward toward the distance of Venus. And finally, weeks later, it moved outward again past Earth's distance from the sun. Mars, Venus, Earth. 3 worlds in that order. Each pass distant enough to be safe, but close enough to provide remarkable observational opportunities. Even as a natural object, that kind of sequence is rare. You imagine the solar system as a hallway of doors, and 3i Atlas drifting down it at the exact height where each handle sits, not opening anything, just gliding by each one, perfectly within reach. When astronomers listed the approximate distances, the pattern grew even sharper. Near Mars's path, about a few dozen million miles. Near Venus's, again within observational distance. Near Earth's, roughly 170 million miles. Far, but ideal for telescopes to gather everything they could. Close enough to study. Far enough to avoid risk. The kind of distances a surveyor would choose if the goal were to observe without disturbing anything. No one is claiming that is what happened. But the resemblance sits there, quiet and unforced. A path that neither crashes nor flees. A path that doesn't dive or scatter. A path that drops into the solar system at its thinnest, flattest, most observable layer. It was not chaotic. It was not wild. It was organized. Astronomers sometimes use the term gravitational threading to describe a technique in which a spacecraft uses multiple flybys to fine-tune its route, slipping through gravitational zones as if weaving a needle through cloth. No one applies that term to 3i Atlas. Its speed is far too great, and its origin too remote. But the comparison helps you understand why the trajectory made so many scientists lift their eyebrows. The flybys weren't random. They weren't messy. They followed a clean, gentle progression that almost resembled a survey path, a way of passing through a region and letting each world's position offer a different angle of view. When asked about it, Avi Loeb offered a comment that was careful but memorable. He said that if someone wanted to observe a planetary system without interacting with it, this is the kind of trajectory they might use. Not because it is artificial, but because it is efficient. Again, nothing here claims intention. Space is vast enough that even rare alignments can happen by chance. But the precision of this one, the angle, the thread through the planetary plane, the sequence of the flybys, the distances, was pattern number 2. And it was much harder to dismiss than the first. You can feel why experts talk quietly when they talk about precision. Chaos doesn't bother them. Chaos is natural. But precision, clean, elegant, recurring precision, that is where their voices soften. That is where the fear enters, not as a warning, but as a weight. Because precision implies structure, and structure implies something deeper. The more precisely this object moved, the more people leaned forward. Not because they were scared of it hitting Earth. It never came close enough for that. But because the path looked nothing like the noisy, messy randomness of most long-period comets. It looked deliberate, not purposeful, just unusually clean. The kind of clean that makes you pay attention. And then, right when the world needed to see it most, something happened that made this entire precise path even stranger. Just as 3i Atlas reached the sun, its exact position became hidden from every Earth-based instrument. The object slipped behind the sun from our point of view, completely swallowed by the glare, a visitor threading the solar system, and then silence. And that silence is where the next part of this story begins. By the end of October 2025, the story of 3i Atlas had already taken on a quiet strangeness. You had the timing, you had the trajectory, Two patterns that were easy to explain individually, but harder to ignore together. And then came the moment that added the third, the object's closest approach to the sun, its perihelion. Perihelion is simple to picture. It is the moment when an object leans in closest to the star it orbits. Or, in the case of an interstellar visitor, the star it merely passes by on its long journey. During this moment, a comet or asteroid usually brightens and reveals its structure: jets, tails, fragments, outgassing. These are the clues astronomers rely on to understand what they are looking at. Perihelion is the cosmic equivalent of an X-ray, a chance to see what lies beneath. But for 3I Atlas, the geometry of the solar system created an unexpected complication. As it curved toward the sun on October 29th, Earth ended up on nearly the exact opposite side of the sun, a straight line of Earth, Sun, and 3I Atlas. From where you stand on this planet, that alignment meant one thing: blindness. The sun's glare drowned everything. Even powerful observatories orbiting Earth, sitting above the atmosphere, could not break through the blinding light. The object disappeared into the solar halo, swallowed by the star's brilliance. For the world's astronomers, it was an uncomfortable moment, the most important part of the object's journey. The moment when it would reveal itself was happening exactly where Earth could not see it. A blind spot, not created by secrecy or failure, but by geometry. And the timing could not have been more precise. 3 weeks when the entire Earth-based system went dark. But Mars was not aligned the same way. While Earth faced the sun head-on, Mars sat at an angle, tipped just far enough to the side that the glare did not overwhelm everything. Its position created a natural side window, an opening through which spacecraft orbiting the red planet could see 3I Atlas as it swung behind the sun relative to us. And so, while the whole Earth looked up into pure brightness and saw nothing, Mars was watching. You imagine the difference. On Earth, even the largest telescopes saw a blank, blinding field of light. Day after day, no updates, no images, no data. A planet of 8 billion people facing the sun and finding only silence. But on Mars, under a thin apricot sky, the scene was different. The cameras circling above the red planet's surface. Mars Reconnaissance Orbiter, with its razor-sharp, high-rise instrument. MAVEN studying ultraviolet emissions and charged particles. And even the Perseverance rover, sitting on the dusty floor of Jezero Crater, all had a view. A small, cold point of light drifting near the sun, but not lost in it. A traveler caught from the corner of another world's eye. It is a cinematic contrast, but a gentle one. Earth staring into brightness, Mars looking through the side window, the universe offering two perspectives, one blotted out, one perfectly placed. You picture the moment. On Earth, frustration, waiting. The sense that the story had paused at the worst possible time. On Mars, a slow-moving glimmer, shifting across the dark, recorded quietly by instruments built for entirely different missions. Machines designed to map dust, rock, climate, and atmosphere found themselves watching a visitor from another star. And this raises the kind of question that settles softly into the mind. Out of all the paths 3I Atlas could have taken, it chose one that hid its closest solar pass from Earth, the very planet most capable of observing it, while leaving a perfect angle open through Mars. Is that meaningful? Not necessarily. It could be pure orbital chance. It could be a coincidence of celestial mechanics with no deeper significance. Planets and objects align in countless ways, and most of them carry no intention at all. But it is a pattern, the kind scientists notice, write down, and file away in the back of their minds. Because sometimes the universe only lets you watch through a side window. And when those windows open unexpectedly, you can't help but pause for a moment and ask why. Not out of suspicion, but out of curiosity. The kind that grows quietly in the space between facts. The kind that says, "This is interesting. This is something to think about." As the images streamed from Mars-based instruments, teams on Earth waited for the moment they could look again. The object, slipping behind the sun from our perspective, continued its journey. The world prepared for the flood of new data that would arrive once the alignment shifted. But instead of a flood, a different kind of silence arrived. Because just as cameras at Mars captured their best images, just as the world was about to learn what the object looked like when it leaned closest to the sun, something happened on Earth that no telescope could prevent. Something human. Something bureaucratic. The government went into shutdown. NASA went quiet. Communications paused. Data releases froze. Statements, briefings, and planned updates were suddenly put on hold. Not because of the object itself, but because of the system that supports the scientists who study it. For weeks, the best data humanity had ever collected on an interstellar visitor sat waiting behind closed doors. Not hidden, not denied, simply locked in place by timing that felt almost unreal. A cosmic object slipping behind the sun, a human institution going silent at the same moment. Two different kinds of blindness, overlapping exactly when the world wanted clarity most. And that is where this chapter ends. With Mars watching, Earth waiting, and silence settling over the most important phase of the object's passage. And just when our cameras at Mars captured their best images, our voices on Earth went silent. As the last images from Mars circled quietly through the deep space network, something unexpected happened on Earth. It had nothing to do with astronomy, nothing to do with space, and nothing to do with 3i Atlas itself. Yet it would shape the way the world learned about this visitor for weeks to come. The closest images of 3i Atlas, the ones taken around October 2nd, just before its descent behind the sun, were captured, stored, and queued for analysis. In any normal year, those images would have been processed, contextualized, and shared through the usual NASA channels. A press briefing, a written update, or at least a release to the scientific community. But right after those images were taken, the United States government entered a shutdown. A shutdown sounds dramatic, but in truth, it is mostly procedural. It means that political disagreements prevent Congress from passing the budget needed to fund federal agencies. And when that happens, the machinery of government slows, pauses, or stops. Websites stop updating. Press offices go quiet. Missions continue operating, but communication becomes limited to essential channels only. When political gridlock pauses the machinery of government, one commentator said, it pauses the voices of the agencies too. including NASA. That was exactly what happened. NASA did not stop observing. Its teams did not stop analyzing. But the public communication, the lifeline between scientists and the rest of the world, went silent. Press releases were delayed. Interviews were postponed. Social media updates froze. All of it because of legal and administrative restrictions that go into effect during a shutdown. And unfortunately, for anyone watching the sky, the timing could not have been worse. The best images of 3I Atlas at perihelion, the moment that could reveal its jets, its fragments, its structure, were taken right as the shutdown began. They were not withheld for secrecy. They were simply trapped behind paperwork, waiting for the government to restart. Amateur astronomers felt the silence first. Forums lit up. Observatories and science communicators began asking when updates would resume. On YouTube, channels that normally received prompt NASA commentary suddenly had nothing new to discuss. On X and Reddit, speculation grew. What did the new images show? Why was everything so quiet? Was NASA seeing something unusual? Was something being hidden? Nothing was being hidden. Nothing was being concealed. But the pattern of timing looked strange from the outside, almost too perfectly misaligned. The moment the world was most eager for information was the moment the system that provides that information shut its doors. You imagine the mood among scientists. They continued analyzing images behind the scenes, preparing reports, discussing features, sharing data within professional networks. But publicly, they could not speak. They could not clarify. They could not reassure or explain or guide the conversation. A single memo from one congressional office even asked for clarification on the object's behavior, not because of danger, but because constituents were asking questions NASA couldn't yet answer. And above all of this human noise, the sky kept moving. The universe doesn't wait for our politics to resolve, one researcher commented quietly. And it's true. While people debated budgets and procedures, 3I Atlas kept flying. It continued curving past the sun, shedding light, dust, and mystery in equal measure. The cosmos allowed no pause, no break, no delay. You can feel the contrast. Above, a visitor behaving in ways no one fully understood. Below, a government paused mid-sentence. A strange, almost poetic mismatch. One world frozen, the other still in motion. For 6 weeks, the silence continued. 6 weeks of waiting for updates that never came. 6 weeks of wondering what the hidden images might show. 6 weeks of whispers, guesses, and conversations that grew more imaginative the longer the silence lasted. You can almost hear the collective question floating through the digital world. What did they see? What are they not telling us? But it's important to keep the tone calm and grounded. You cannot claim that NASA was hiding anything. There is no evidence for that, and every indication suggests the opposite. The scientists were simply unable to speak. Their hands were tied not by intention, but by procedure. Still, the timing couldn't have been worse. By the time the shutdown ended, the pressure had built like water behind a dam. People wanted answers, not wild theories, not speculation, but clear, steady, scientific clarity. They wanted to hear what the images showed, what the instruments measured, what the experts thought. And while the world waited, another layer of mystery was forming. Not in the offices of NASA, but in the sky itself. Because while Earth was silent, 3I Atlas had been busy. As it rounded the sun, It performed a series of brightening events, structural changes, and survival feats that would unravel even the most confident expectations. The silence was about to break, and when it did, the images raised more questions than answers. It was the worst possible time for a shutdown, an online commentator joked, and the best possible time for conspiracy theories. 6 weeks passed. The world refreshed NASA's website like people waiting for a verdict. And when the agency finally spoke, the story grew even stranger. By the time NASA finally spoke, another mystery had already unfolded around the sun. When the world finally regained its ability to watch the sky, 3-Eye Atlas was already rounding the sun. October 29, 2025. Perihelion. The moment when this interstellar visitor leaned closest to our star. If there was ever a time when it should have revealed its true nature, this was it. And if there was ever a moment when it should have fallen apart, this was that moment, too. Perihelion is brutal. It's the region where sunlight becomes a force that can tear molecules apart, where radiation grows fierce enough to scorch surface layers instantly, where the solar wind strikes like an invisible storm, stripping material from anything fragile. And through all of this, gravity twists paths and bodies with enormous pressure. Most comets barely survive the experience. Many don't survive at all. But 3-Eye Atlas did something few expected. As it curved into the sun's harshest light, its brightness surged. Not gradually, not gently, but in a sudden, astonishing eruption. Telescopes measuring its luminosity saw it brighten by a factor of 100 in a remarkably short span of time. For a comet, this wasn't just unusual, it was extreme. A dramatic outburst, the kind that usually signals something catastrophic happening beneath the surface. Normal cometary outbursts come from trapped gases heating up and exploding outward, like steam blowing through cracks in ancient ice. But this was different. The spike in luminosity was sharper, stronger, and far more energetic than any standard model predicted. It was as if the object had flared, as if something inside it had ignited and vented violently. For a moment, astronomers thought they were witnessing the beginning of its end. Fragmentation reports started circulating from the earliest processed images. Some early analysis suggested there might be as many as 16 pieces emerging around the main body. Potential fragments, debris, or jets dense enough to mimic detached chunks. In the hours that followed, the chatter grew. Maybe it was breaking apart. Maybe the visitor was disintegrating under the sun's heat. Maybe this was the last chapter of its journey. But then, the follow-up images arrived. And what they showed didn't match the story of a dying comet. The core remained intact. The central structure, whatever shape it truly held beneath the haze of gas and dust, appeared strangely solid. It had shed material, yes. It had erupted, yes. But it had not collapsed. It had not shattered. The supposed fragments looked more like clustered outflows or temporarily illuminated jets. The main body didn't behave like something falling apart. It behaved like something enduring, almost as if it had broken without breaking, a contradiction that made scientists pause. Then came the feature no one expected, the anti-tail. Under normal physics, a comet's tail always points away from the sun. Solar radiation pushes dust outward, like a breeze pushing smoke. But 3-Eye Atlas displayed something far more complex. One structure pointed away from the sun, expected, natural. But another, fainter structure seemed to extend toward the sun. A tail and an anti-tail. A jet pointing both directions at once. It was like watching a torch burn in two opposite directions. One flame blowing outward into the night, the other bending inward toward the fire that should have burned it away. Scientists scrambled for explanations. And explanations existed, some based on viewing angles, some on dust sheet geometry, some on the unusual speed of the object. But even within those frameworks, the feature stood out as something that demanded closer inspection. The mathematics only made things stranger. To generate the amount of visible material seen in the images, the object would have needed to shed an enormous amount of mass in only a few days. Avi Loeb offered an estimate in one of his interviews. Perhaps 13% of its total mass lost almost instantly. 13%. For a natural comet, that kind of mass loss is catastrophic. It is the difference between a visitor and a ruin. A comet losing that much material so quickly wouldn't look stable. It would look like debris. A cloud. A field of fragments. But 3i Atlas refused to follow that script. It didn't dissolve. It didn't collapse. It didn't vanish into dust and shards. Instead, it emerged from perihelion still intact, still bright, still holding together in a way that contradicted what its own outburst should have done to it. This is where the sense of unease comes in. Not fear in a dramatic sense, but the quiet kind that settles in the minds of experts when something breaks the rules. Not because the rules are wrong, but because the object is not behaving the way the rules say it should. When something survives what should have destroyed it, one researcher noted, experts feel less certain and more afraid of what they might be missing. No one argued that this was proof of anything artificial. No responsible scientist would jump to that conclusion. Natural objects can be strange. Nature can be violent, unpredictable, and full of surprises. But taken together, the timing, the trajectory, the brightening, the mass loss, the survival, the anomalies stacked on top of each other like steps in a growing staircase. Each one could be explained. All of them together felt harder to ignore. The anti-tail, the sudden surge, the contradictory fragmentation, the endurance. These formed a pattern, not one that pointed clearly in any direction, but one that hinted the story was far from simple. And as 3i Atlas pulled away from the sun, cooling, dimming slightly, and drifting back into the reach of radio instruments, something else happened. Something quieter, subtler, and stranger than brightening or fragmentation. It wasn't visible in photographs. It wasn't obvious in optical data. It came through the whisper of radio waves, a signature, a burst, a moment that made astronomers sit forward and listen. The universe had more to say. As it pulled away from the sun, another clue emerged. Not in visible light, but in radio. When 3i Atlas emerged from behind the sun, its brightness still unsettled observers. Its survival still puzzled them. Its strange dual tail still lingered in everyone's mind. But in the middle of all those anomalies, in the middle of the outbursts, the mass loss, the fragmentation that wasn't fragmentation, something else appeared, something quieter, something far more ordinary, and somehow that ordinary signal made the whole story feel even stranger. Around October 24th, just days before perihelion, radio telescopes in South Africa detected a familiar emission line coming from the region of sky where 3i Atlas was traveling. It wasn't a message. It wasn't a pattern of pulses. It wasn't anything artificial at all. It was hydroxyl. Hydroxyl, OH, is the daughter product of water exposed to intense solar radiation. When sunlight strikes water molecules, it breaks them apart. One piece becomes hydrogen, the other becomes hydroxyl, and hydroxyl emits a signature at a well-known radio frequency. Astronomers use that signal all the time to identify comets rich in water ice. It's a normal, expected part of comet behavior. So why did it matter here? Because until that point, 3i Atlas hadn't behaved like anything normal. The object had arrived with a trajectory too precise to ignore. It had brightened 100-fold in a way that didn't match simple heating. It had produced jets pointing both away from and toward the sun. It had lost perhaps 10% or more of its mass in days, and yet refused to disintegrate. And through all of this, clear evidence of water had been strangely elusive. So when the hydroxyl line finally appeared, astronomers felt two simultaneous reactions. The first was relief, the kind that comes from finding something familiar in a sea of unknowns. The second was confusion, because the timing didn't line up with the models. The signal wasn't weak. It wasn't subtle. It was strong enough to confirm that water was present in meaningful quantity. It was as if, after months of behaving like nothing we knew, the object suddenly started checking boxes on the comet list. For many people watching online, the word radio did what it always does. It sparked imagination, messages, patterns, signals. The human mind loves stories that sound like communication, especially when the data arrives wrapped inside mystery. But this wasn't one of those stories. This wasn't a whisper from another civilization. It was simply sunlight breaking apart water, a routine chemical event heard across space. And yet, the context made it impossible to dismiss. The signal showed up at a moment when the object was already proving difficult to categorize. It appeared right after an outburst so violent it should have torn 3i Atlas apart. It strengthened after a perihelion pass that should have erased any fragile chemical signature. And it arrived during a time when Earth couldn't see the object directly, and NASA couldn't release information even if it wanted to. Sometimes a normal signal appears at a very abnormal time, and that timing can be enough to make experts pause. Not because there is anything unnatural about hydroxyl, but because it joined a list of oddities that was already getting too long for comfort. Each detail alone was explainable. Together, they built a puzzle. This is where tone matters. It's important not to exaggerate. Hydroxyl lines are common. They do not imply technology, intelligence, or intention. They are chemistry, pure, simple chemistry. And yet, dismissing them entirely would ignore the way real scientific curiosity works. No one was saying, "This is alien." But many were saying, "This is interesting," because the signal did more than confirm that water existed on or within the object. It revealed that something had changed. Before perihelion, observations struggled to find strong water signatures. After perihelion, after the flare, after the mass loss, after the survival, the hydroxyl appeared clearly. A dramatic event happens. The object survives. And then it suddenly behaves more like a comet than before. If it wanted to maintain plausible deniability, This is exactly how you'd expect it to behave. But again, the story isn't about suspicion. It's about curiosity, the kind that grows quietly in the spaces between anomalies, the kind that doesn't jump to conclusions, but also doesn't look away from patterns. Hydroxyl was a comfort to those who wanted a simple explanation. But as Avi Loeb once phrased it, hydroxyl is a comfort for those who want a simple comet. But timing is everything. And timing is what made this ordinary signal feel not entirely ordinary. By early November, the world was ready for clarity, ready for structure, ready for NASA to step to the microphone and explain what the images showed, what the radio data meant, and how all these pieces fit together. People didn't want hype. They didn't want fear. They wanted grounding, the kind of calm, steady explanation that only NASA could give. So when the shutdown ended and November 19th arrived, the world held its breath. After weeks of silence, after the perihelion drama, after the strange signals and stranger survival, NASA finally spoke. People expected clarity. Instead, they got a fuzzy ball and even fuzzier answers. So when November 19th finally arrived and NASA broke its silence, the world expected clarity. Instead, it got a fuzzy ball and even fuzzier answers. By November 19th, 2025, the silence had grown heavy. 6 full weeks without a briefing. 6 weeks without clarity. 6 weeks where the world kept refreshing web pages, waiting for NASA to speak. Astronomers, reporters, YouTube educators, Reddit threads, and every corner of the sky-watching community were ready for answers. After perihelion's heat, after the strange brightening, after the survival that shouldn't have happened, people expected this day to bring definition. Instead, it brought ambiguity. The room where NASA held the press conference looked as serious as any major scientific briefing. A clean stage, muted lighting, quiet tension. Cameras lined the back. The presenters took their places. Behind them, a set of carefully prepared slides waited. The first official images released since the shutdown. When they finally displayed the data, what appeared on the screen was a blur, a dim, fuzzy glow, a smoothed-out circle with no visible structure, no jets, no fragments, no contours, no detail at all. There it was, the object everyone had been waiting to see for 6 weeks, a fuzzy blob. And then came the statements, delivered with the calm tone NASA always uses when walking the line between clarity and caution. We see nothing that suggests non-natural origin, one presenter said. It looks and behaves like a comet, another added. These were the 2 lines that echoed across the world within minutes. They were simple, non-alarming, designed to keep speculation manageable. But beneath the reassurance lay something deeper. Not deceit, but vagueness. Because while NASA emphasized what the object wasn't, they offered remarkably little about what it was. The missing pieces spoke louder than the statements. For one, they did not address the unusual CO2 to water ratio reported earlier, a ratio far higher than typical comets. They did not discuss why water signals appeared so late, or why they strengthened only after perihelion. They mentioned the brightening, but offered no detailed explanation for why the spike was so extreme. The fragmentation question, whether the object had broken into many pieces or simply looked that way, received no direct answer. They also gave no clarification about the sunward jet. In the images shown, it wasn't visible, and yet Independent analyses had detected it earlier. NASA neither confirmed nor denied, leaving the feature floating in ambiguity. And perhaps most noticeably, they did not share any of the anticipated high-resolution images from the Mars Reconnaissance Orbiter's HiRISE camera. The world expected razor-sharp visuals. Instead, the release consisted of over-processed brightness maps and smooth data plots. It felt like watching a weather radar image where a photograph should have been. The reaction in the scientific community was immediate and conflicted. Some shrugged and said, "Okay, that's it." Others were more direct. "How is this all they have after 6 weeks?" Social media lit up. Not with conspiracy theories, not yet, but with genuine confusion, because the unanswered questions were many. Did it fragment or not? Why was the outgassing pattern so asymmetric? Why did spectra differ so widely between different instruments? Why was the perihelion brightening so extraordinary? Why did key Mars-based images remain unavailable? These were not sensational questions. They were normal scientific ones, and the press conference left all of them hanging. The presenters repeated the word comet several times, as if saying it enough would make the label fit more comfortably. But it didn't quite land. Not because comets can't be strange, they absolutely can, but because this one carried too many contradictions. A comet losing more than 10% of its mass in days should look shredded. A comet with a sunward jet shouldn't hold together this well. A comet that brightens 100-fold should show visible structural changes. A comet entering the solar system 8,000 years ago with a near-perfect ecliptic alignment shouldn't be treated as ordinary. It wasn't that NASA lied. It wasn't that NASA covered anything up. It was simply that the official explanation felt too neat for the data people had already seen. That's when a softer, more philosophical realization crept in. Sometimes, the simplest explanation is offered not because it is true, but because it is comfortable. And on that day, comet was the most comfortable word in the room. But one person wasn't satisfied. Almost immediately after the conference, Avi Loeb released his own commentary. Not an accusation, not an attack, but a counterweight. He published a list summarizing 12 anomalies, each pulled directly from observational data. Nothing sensational, nothing speculative, just patterns laid bare one by one. It was a nudge to the scientific world. Look again. Don't close this file yet. And in that moment, the mood shifted. NASA said, comet. The data said, something is off. The world found itself back in the gray zone, the quiet region between certainty and possibility, where curiosity grows loudest. 6 weeks of waiting had ended, but instead of clarity, the story had only deepened. And maybe that's why this part of the journey felt so strangely human. The universe had behaved with dramatic complexity. People, in contrast, responded with careful caution. Institutions leaned toward simplicity. Researchers leaned toward questions. And those watching from afar felt both pulled in and kept at arm's length. The more NASA talked, the less anyone felt they understood. So let's lay out the patterns, one by one, and ask the question NASA couldn't answer. By the time NASA finished speaking, a strange quiet settled over the scientific world. Not because the mystery had faded, but because something else had become undeniable. Everything still felt unresolved. One explanation it looks like a comet, now stood against a growing list of details that refuse to align neatly beneath that label. And this is where the story reached its intellectual peak. Not in the drama of brightening or fragmentation, but in the steady stacking of patterns. One anomaly is curiosity. 2 is coincidence. 12 is fear. Not fear of danger, not fear of catastrophe, but the quiet, intellectual fear that comes when your models no longer feel large enough to hold what you're observing. So here are the 12 anomalies, clearly, calmly, one by one. 1. The timing anomaly. The trajectory reconstruction showed that 3I Atlas entered the solar system around 8,000 years ago. On cosmic scales, that's a blink. On human scales, it aligns with an extraordinary moment, the birth of written history. Sumerians carving symbols into clay, Egyptians building the Old Kingdom, the Indus Valley rising, China's earliest dynasties forming, the same era when humanity first looked at the sky and began recording what it saw. Statistically irrelevant? Maybe. Philosophically haunting? Absolutely. 2. The orbital plane anomaly. 3I Atlas arrived only 5 degrees off the ecliptic, the thin plane where all major planets orbit. Thousands of approach paths exist. Most comets come in at steep or random angles. This one threaded the flattest, cleanest lane, like tossing a dart across an ocean and hitting the line between 2 numbers. 3. The approach sequence anomaly. As it moved inward, it passed near Mars, then Venus, then Earth, in that exact order. Far enough to be safe, close enough to observe. A sequence that looked less like a plunge and more like a survey. 4. The perihelion blind spot. Its closest solar pass, the moment with the most data-rich revelations, happened in the one alignment where Earth was completely blinded by the sun. But the angle left Mars with a perfect side view. A closed door facing Earth, a window open on Mars. A coincidence with poetic geometry. 5. The brightening anomaly. Just before perihelion, its brightness increased by a factor of 100, not gradually, not gently, suddenly, violently. A spike far beyond typical comet behavior. A flare that made astronomers wonder if the object was tearing itself open from within. 6. Fragmentation, but not fragmentation. At least 16 potential fragments appeared around it in early imagery. Yet later observations showed the main structure intact. It was breaking, without breaking, behaving like a shattered object and a unified one at the same time. 7. The sunward jet anomaly. Comet tails point away from the sun. Always. Solar radiation guarantees that. Yet 3I Atlas produced a faint jet or dust structure pointing toward the sun, as if a torch were burning in both directions, outward and inward. 8. The mass loss paradox. To create the cloud of material detected around it, the object may have lost 13% of its total mass in days, enough to destroy most comets entirely. But 3I Atlas simply kept going. A natural object shedding catastrophic amounts of mass should collapse. This one didn't. 9. The CO2-H2O ratio anomaly. Its ratio of carbon dioxide to water vapor didn't match typical comets. Some comets have unusual chemistry, but the readings here push the boundaries of what normally appears in solar system objects. 10. The hydroxyl timing anomaly. Hydroxyl radio emissions, the signature of solar radiation breaking water apart, appeared strongly only after perihelion. Before that, water signatures were faint or ambiguous. After the flare, suddenly the OH line was clear. It was as if something about the object changed, or revealed itself, just when scrutiny was highest. 11. The shutdown silence anomaly. The timing of the U.S. government shutdown meant that the best perihelion images were withheld for 6 weeks, not intentionally, not conspiratorially, but legally, and at the worst possible time, a cosmic mystery colliding with a bureaucratic pause. 12. The public image anomaly. When the long-awaited images finally came, they weren't the high-resolution frames the world expected. They were overprocessed, low contrast, softened to the point of being featureless. 6 weeks of anticipation for a blurry circle. These 12 anomalies don't tell a story of danger. They tell a story of patterns layered on top of patterns. The kind of stacking that makes experts shift in their chairs, not because they fear the object, but because they fear what it means for their understanding of the universe. What do experts fear most? Not that 3i Atlas is artificial, not that it is threatening, not that it is anything Hollywood would imagine. Experts fear rewriting models, the lifelong frameworks that explain how objects move, how comets behave, how physics shapes matter across space. They fear missing the signal, the possibility that behind the anomalies lies something important that future generations might wish we had noticed. And they fear that the universe may be more intentional than we assumed. Not in a conscious sense, but in the sense that patterns might reveal deeper laws we haven't uncovered yet. 12 anomalies, one object, each explanation reasonable on its own. All of them together, statistically extravagant. Avi Loeb put it plainly. If these patterns are natural, then we need new definitions for natural. This doesn't prove anything unnatural. It doesn't even point to a specific conclusion, but it does force a shift in perspective. The recognition that 3i Atlas may be the strangest natural object humanity has ever observed. And that alone is enough to make even confident experts quietly uneasy. Because while the past reveals the patterns, the future reveals their meaning. 12 anomalies is the story so far. What matters next is what comes next. And now, all eyes turn to the dates that could change everything. The past has already given us its patterns, the timing, the trajectory, the brightening, the survival. The 12 anomalies stack behind us like footprints marking where we've walked. But now the story shifts. Not backward, not inward, but forward. Toward the moment still coming. Toward the 2 dates that astronomers circle in red on their calendars. Not with fear, but with a quiet sense of history unfolding in real time. The first is December 19th, 2025. On that day, 3i Atlas reaches its closest point to Earth, about 170 million miles away. A distance vast by human standards, but close in astronomical terms. Close enough for clarity, too far for any risk. It is, in every sense, completely safe. But safety is not why this date matters. This date matters because Earth will finally have the perfect geometry to look again, clearly, deeply, without the blind spot of the sun or the silence of a shutdown. For the first time since perihelion, the world will see 3i Atlas with every instrument pointed in its direction. Not through the side window of Mars, not through scattered radio traces, through the full power of our observatories. What can those observatories do? They can study its spectrum. reading the chemical fingerprints of the gases it releases. They can scan its color index, seeing whether it shifts toward blue, red, or something unexpected. They can map the direction of its jets, tracing outgassing patterns to determine rotation, structure, or stress fractures. They can examine the dust morphology, the shape of the tail, the gradient of particles, the curves that tell stories about its internal physics. They can observe it in infrared, revealing heat signatures invisible to the eye. For the first time since the object arrived, the instruments we built for distant galaxies and dying stars will focus together on the same visitor. And the possibilities open like a branching tree. Scenario A. It behaves like a comet. The brightening settles. The fragmentation stabilizes. Jets appear in expected directions. Spectra match known behavior. If this happens, the mystery softens. It becomes the story of a strange but ultimately natural object. Extraordinary, but not paradigm shifting. Scenario B. Jets behave unpredictably. If new jets appear in sunward or lateral directions, or if outgassing patterns diverge from rotation models, the anomaly count rises. It hints at internal structure far more complex than frozen rock and ice. Scenario C. Brightness changes non-linearly. If its luminosity flares or collapses in ways poorly tied to sunlight or geometry, it suggests deeper processes that require new modeling. Scenario D. Fragments appear or follow. If small bodies cluster behind it or drift away from it, the implications would be significant. Clustering could mean break-off events, or something stranger. This scenario, while unlikely, represents the highest anomaly outcome. But December 19th is only the beginning. The second major date is March 16th, 2026. By then, 3I Atlas will be approaching the distant gravitational influence of Jupiter, the edge of the giant planet's Hill sphere, where its gravity begins to dominate the region around it. Most objects pass through without incident. Their trajectories shift smoothly, predictably, obeying the mathematics we teach in physics classrooms. But if 3I Atlas does something unusual there, something that defies the expected curve, astronomers will feel that shift immediately. A subtle deviation at Jupiter's boundary would ripple outward into every model. It could mean mass redistribution. It could mean non-gravitational acceleration. It could mean internal mechanics we don't understand. Another possibility sits even farther on the edge of imagination: clustering. If new, small objects appear near it, or if debris follows in patterns too organized to be random, it would force a major theoretical shift. Not a frightening one, but a profound one. It would mean this object is more dynamic than anything we have seen before. None of these scenarios imply danger. All of them imply discovery. And that is the spirit of this chapter. Not alarm, but anticipation. You are not listening to a warning. You are listening to a moment in history that very few humans will ever experience firsthand. Most people who lived on Earth never witnessed an interstellar visitor. Most never saw something from another star pass through the sun's light and come out the other side. Most never lived in a time when the universe reached across millions of years and left a question at our doorstep. But you are. You are living inside a cosmic event, one we may not see again for centuries. And the strangest part is not how unusual 3i Atlas has been, but how much of its story still lies ahead. The anomalies behind us are the prelude, the opening chapters. What comes next will decide what this object truly becomes in the history books. Maybe it fades quietly. Maybe it reveals new features. Maybe it adds another anomaly to the list. Or maybe, in the gentlest twist of all, it becomes ordinary again. Out of all the possibilities, that one may be the hardest to imagine. Because when you've watched something defy expectations 12 times in a row, normalcy suddenly feels like the rarest outcome of all. Avi Loeb once put it in simple words: whatever happens next, 3i Atlas is already the most interesting visitor we've ever had. And that's the heart of this moment. Not fear, not hype, not anxiety or speculation. Just a calm understanding that we are witnessing something real, something large, something timeless, something that reminds us that the universe is active, evolving, alive with motion and complexity. It also reminds us of humility. We observe not because we fear, but because we're humbled. Because the universe is older than every book we've written, every telescope we've built, every story we've ever told. Because sometimes the only honest reaction to something extraordinary is curiosity. Pure, steady, gentle curiosity. 12 anomalies explain where we've been. December 19th and March 16th reveal where we're going. The future of this story has not been written yet, and we are here to witness it. But tonight, the universe is quiet, and so are we. As 3 Atlas drifts farther from the sun, its glow softens. The sharp brightness that once startled astronomers fades into a gentle smear of pale light, stretching across the cold dark like a breath slowly released. You picture it now, not as an anomaly or a puzzle, not as a list of questions waiting for answers, but simply as a distant traveler disappearing into deeper space. Its tail thins, its jets quiet, its presence loosens into the background of the universe. And somewhere in that dimming, the fear that wrapped itself around this story begins to dissolve too. Because the truth is, the fear was never about danger. This object was never a threat. It never came close enough to harm us, never altered its path toward us, never behaved in ways that suggested anything hostile or intentional. Its strangeness was scientific, not existential. Its questions were intellectual, not survival-based. The real fear, the quiet one experts rarely voice aloud, is something gentler. It is the fear of not understanding, the fear of being humbled, the fear that the universe is larger, stranger, richer than our models can hold. And when you sit with that feeling long enough, you begin to realize something even softer. Fear is just another word for respect. Respect for the unknown. It does not push you away. It draws you in. It reminds you that curiosity is an act of courage, and wonder is a way of listening. Even now, as the object fades, it leaves behind no threat, no warning, no omen. Only questions, only fascination, only the small, bright spark of possibility. The reminder that the universe still contains surprises, even after all this time. You imagine the solar wind now, brushing gently past the remnant grains of dust, a thin whisper, softer than any breeze on earth. The space around it is calm, wide, unhurried. Shadows stretch endlessly. The blackness becomes a soft curtain rather than a void. The planets continue their slow arcs, turning the same way they always have, Earth rotates under your feet, steady and patient, carrying you through the night one quiet mile at a time. The sky above you is still. The air in your room is still. And in this stillness, something inside you unwinds. Whatever three-eye atlas is, whatever story it carries, it moves through the cosmos without malice. It doesn't seek us. It doesn't chase us. It doesn't judge or disturb or alter anything about our world. It simply drifts. A visitor passing by, a silent messenger with no message except its existence. And you, here on Earth, are safe. Your life is small in the best possible way. Your worries are earthbound, human, manageable. This story is big, yes. Wide as orbits, long as centuries, deep as cosmic time. But your world remains calm. The ground beneath you is steady. The night around you is gentle. The dangers of the day are gone. And the universe, for all its mystery, watches over you quietly. You feel the air settle. You feel your shoulders drop. You feel your mind loosen, uncoiling from the long thread of questions. This is the moment when mystery becomes peace. When the unknown stops pressing against your thoughts and starts rocking them into stillness. The kind of stillness that helps you sleep. The kind of stillness that reminds you that not everything needs to be solved tonight. Some things are allowed to remain beautiful, unresolved, drifting. You've listened to the story of something vast, something old, something that began its path long before you were born and will continue long after you are gone. And yet, it touched your life. In this moment, through this quiet curiosity, through this sense of being part of something larger, that alone is enough. You don't need to know what Three-Eye Atlas truly is. Not tonight. You don't need to answer the 12 anomalies. You don't need to predict December or March or what comes after. The patterns will unfold. The data will come. Scientists will do what they do best. Observe, question, refine. And you get to rest. Curiosity keeps you awake in the best way. Stillness lets you sleep in the deepest way. Both are gifts the universe offers freely. So as this visitor drifts into the distance, let your thoughts drift with it. Away from noise, away from tension, into the soft, dark ocean of space. The same ocean that has carried travelers for billions of years. The same ocean that cradles our tiny world like a stone floating in an infinite pond. You breathe out. The night settles. You are safe. The universe is quiet. And whatever tomorrow brings, the stars will still be there when you open your eyes again. Good night, traveler.